Okay, we're going to find the domain from an equation. So you know that your domain is all of your x values, right? And looking at a graph, it's how far left and right it goes. But if we don't have a graph, if we just have an equation like some of the ones down here, you're going to always assume that if you see an x, you can plug in any real number. So your domain, by default, is all real numbers. Okay, and most of your answers are going to be all real numbers, which is negative infinity to infinity. But we have a few restrictions. One of them is that you can't have a negative under a radical. Okay, that's not a real number, it's an imaginary number. And you also cannot have a 0 in the denominator because we can't divide by 0. So if you don't see a negative in a radical, if you don't see a radical, then it's going to be all real numbers. If you don't see a fraction, then it's going to be all real numbers. If you don't see either one of these two, it will be all real numbers. So let's look at our first example right here. The f of x equals 9x plus 5. What's my domain? All real numbers, negative infinity to infinity. Do I have a fraction or a radical? Nope. Look at the next one. Okay, yeah, it's a trinomial, but the domain is all real numbers. Okay, what could I plug in for x? I could plug in anything. I could plug in a 1 or a 7 or a 1/2. Right? I will get something back out. Look at the third one. The third one, once again, is all real numbers. So if you don't see a fraction or radical, your domain is going to be all real numbers. Now, let's look at these two examples down here. Look at this one. Do you see a fraction? Yes. That means that if you have a 0 on the bottom, you have a domain restriction. Now, how would you get a 0 on the bottom? Is there an x down there? Yep. So some people might be able to look and say, oh, what would you plug into that x to get a 0 on the bottom? But what you should do is you should take your denominator and you should say that denominator cannot be equal to 0. So we've made a statement that the denominator cannot be equal to 0. And then you solve that. Subtract 15 on both sides to get the x by itself. And you will see that x cannot be equal to negative 15. That's the number, negative 15, that if we plug right here, we'll get a 0 in the denominator. So how do we write that in interval notation? Well, it's going to be all real numbers except for negative 15. So it's everything from negative infinity to negative 15, and then we stop at negative 15. And it's going to be in union with everything from negative 15 to infinity. Okay, so my first interval right here includes every number all the way up to negative 15, but not negative 15. That's what this parenthesis is for. So it includes negative 14.9 and negative 14.99999. Goes all the way up to negative 15, but does not include negative 15. And guess what? As soon as you hop on the other side of negative 15, that's where it starts up again. Right? This parenthesis says that the negative 15 is not part of my solution, but as soon as you get to negative 15.0001, it will be. So this is the domain. Okay, all real numbers except for that one point that has parentheses. Now what about this one? F of x equals the square root of x minus 18. Okay, normally my domain is all real numbers, but here, look under the radical. Whatever's under the radical cannot be negative. So it has to be greater than or equal to 0. So to answer this question, I take what's under the radical, the x minus 18, and I say that that has to be greater than or equal to 0. Now I solve to get my x by itself. I'm going to add 18 to both sides. And I'm going to see that x is greater than or equal to 18. That's my domain for this one. If I plug in an 18 right here, guess what? I'm good. If I plug in a 19, I'm good. a 20, I'm good. But as soon as I plug in something that is not greater than or equal to 18, if I plug in a 17, I'll be left with a negative inside a radical. So how do I write this in interval notation? X is greater than or equal to 18. Well, from left to right, I start at 18, and I go all the way to infinity. Infinity always gets a parenthesis. And 18, is this included? Is it equal to 18? Yeah, it's greater than or equal to. So I'm going to use a bracket. So this is my domain.